Welcome to Al-Afaq International School Jeddah Virtual Learning Classroom. With you, Ms. Dina Badawi, physics teacher for grade 7. Let's start our lesson today, but first we will talk about our lesson is chapter 4, lesson 2, forms of energy. The instructions, listen to the lesson's explanation, open your textbook page 114 till page 116, check your answers, give a star to each correct answer. Our standards.
Good morning, Miss.
Good morning. MS forces and interactions, BS2B types of interactions. Our objectives explain how to determine the object's mechanical energy, list other forms of energy. Okay, let's start now our lesson. But before I start, I want to revise with you what we took before. Can you remember, girls, what is kinetic energy? Or we said before, we have two major kinds of energy. What are they? What are they? Who can say? Please start. Yara, you can?
Yes, Miss.
What are the basic kinds of energy?
Kinetic energy and potential energy.
Excellent. Okay, Haneen, what's the meaning of kinetic energy? Haneen, can you say what's the meaning of kinetic energy?
It's the energy of an object due to its motion.
Excellent, excellent. Okay, Saja, can you calculate how, or tell me how can we calculate the kinetic energy of an object?
Half times mass times speed squared.
Excellent, excellent. Okay, Alia, do you know what's the unit of the kinetic energy?
Joule?
Yes, again?
Joule?
Excellent, thank you so much. So the first kind, or the first basic kind of energy, is the kinetic energy, which is energy of motion. Any object in motion has the ability to do work due to its motion. We can calculate kinetic energy by multiplying half times mass of the object times its speed to the power 2, and its unit is joule. Excellent. What about the potential energy? Who can tell me? Zaina, what's the meaning of potential energy in brief?
The energy stored in an object.
Yes, again?
The energy stored in an object.
Excellent, excellent, Zaina. Thank you. It's the stored energy. Excellent. What are the kinds of potential energy just mentioned inside your book? We have only two kinds. Who can tell me? Noura, can you? Noura is here.
Miss, can I say?
Okay.
Yes, can I say?
Okay.
Miss, I'm here.
Gravitational potential energy and elastic.
Okay, you are Imara?
Yeah.
Yes, thank you. Thank you. Okay, Noura, gravitational potential energy. How can you define it? It's the energy due to what? The objects? Due to its position. Yes, due to the object's position.
Yes.
When we do a work on an object to lift an object to a certain height, the work that I did on this object is stored inside it in the form of potential energy. Noura, how can I calculate the potential energy? The gravitational potential energy. How can I calculate it?
Miss, weight multiply height.
Excellent. Weight multiplied by height. Excellent. What about the other kind of potential energy, remass? The other kind of potential energy is called what?
The elastic potential energy.
Excellent. Elastic potential energy. Can you define it?
Yes, Miss, is the energy associated with objects that can be compressed.
Compressed or stretched. It's the energy stored in elastic objects that can be compressed or stretched. Excellent. Okay. Who else? Who can answer? How can I? Okay. What is the unit of elastic potential energy or gravitational potential energy? Its unit is joule. Also, any kind of energy. Okay. Let's start our new lesson today. Can you see the page now?
Yes.
Can you see this page? 114?
Yes.
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 It's okay. In our lesson, we will know what's the meaning of mechanical energy. What is mechanical energy? We said before, the two basic kinds of energy of an object are the kinetic energy and potential energy. So the sum of kinetic energy and potential energy of an object is its mechanical energy. Yes, yes. The mechanical energy of an object is the sum of its kinetic energy and its potential energy. So I can define the mechanical energy by combining the two definitions of both. So it's the form of energy associated with motion. Until here, I'm talking about kinetic energy. What about if I say it's the form of energy associated with motion, position, gravitational potential energy, shape of an object, shape, elastic potential energy. So when I combine these three definitions together, this means mechanical energy. It's the form of energy associated with motion, position, or shape of an object. So what is the form of energy that is associated with shape, motion, or position of an object? This means what? Mechanical energy. This means mechanical energy. So mechanical energy, it's the form of energy that is associated with the motion, position, or shape of an object. Okay? Okay, how can I calculate this mechanical energy? We can calculate the mechanical energy by adding both kinetic energy and potential energy, by adding the kinetic energy and potential energy. Okay. Okay, we can have, sometimes some objects can have both kinetic and potential energy at the same time. Like, wait girls, I'm waiting for the book, for the page to open. Okay, if not, I will just, okay. Some objects may have both kinds of kinetic energy and potential energy at the same time, while others may have only one kind of potential, may have only potential energy, or may have only kinetic energy. For example, please look at these balls, this basketball. It's one ball, but I will throw it like this. Can you see its path? Okay. Since this ball, I lift it from the floor, first of all, this player lift it up, yes? When he lifts it up, now it has which kind of energy? Due to its position, it has gravitational potential energy. Because when he lifts it up, it was down. He lifts it up. He did a work in it, and all this work is transferred to this ball and is stored inside it. This stored energy due to its position is called potential, gravitational potential energy. It's called what? Gravitational potential energy. Okay, girls? Gravitational potential energy. Okay, girls, this is called gravitational potential energy, as it's due to the energy stored due to its position. Then this player will start to throw this ball. So the ball will move. So what it will have again? More, due to its motion, the ball will have which kind of energy? Kinetic energy. Excellent. So it was first just potential energy, then it moves. It will have kinetic and potential. As we go up, what do you think? The potential, the gravitational potential energy will increase or decrease? We said increase. The gravitational potential energy is the energy due to its position, equal weight multiplied by height. So as we increase the height of the object from the floor, the potential energy or the gravitational potential energy will be increased. and the kinetic energy will be, if the motion increase, so the kinetic energy will also increase. Okay, let's try to answer these questions. To calculate the mechanical energy is the sum of both potential energy and kinetic energy, the sum of both of them. Sometimes an object's mechanical energy is its kinetic energy or potential energy only. For example, if I just put the book on the shelf, like what we said when we explained our lesson, I just put it on the shelf, I lift it up and put the book on the shelf, then all my work will transfer to this book and stored as gravitational potential energy. So it will have only gravitational potential energy. It's at rest, it has no kinetic energy. So what is the mechanical energy? Mechanical energy is potential energy plus kinetic energy. The whole value is for the potential energy because I have no kinetic energy. Another example, if a car is moving along a flat street, this car, due to its motion, has kinetic energy, but it's in touch with the flat street, no height, it's not lifted up from the street, so it has no potential energy, so it has just kinetic energy. So all the mechanical energy is the value of the kinetic energy. So mechanical energy is the sum of potential energy and kinetic energy. Maybe both of them have values, maybe one is 0 and the other only has value. Okay, again this figure. In this case, when he is throwing the ball, potential energy is 12 joules, kinetic energy 10 joules. What about the mechanical energy? Who can answer with me?
22.
Excellent. We will say at first we have to write the formula or the equation. Mechanical energy equal the sum equal potential energy plus kinetic energy. So equal 12 joules plus 10 joules equal 22 joules. Excellent. Okay, what about number B? In this, if you notice, the potential energy increased due to its height, while the kinetic energy decreases because the ball here slow down. So the speed decreases, so the kinetic energy decreases. So what about the mechanical energy here? Equal to the sum of potential energy and kinetic energy. 20 plus 2 also equal 22 joules. So the mechanical energy is conserved in these cases. At first, less potential energy, more kinetic, then more potential, less kinetic. But the sum of the mechanical energy or the value of the mechanical energy is the same. Okay, girls? So in most cases, we will find that the mechanical energy, unless, if not, there is friction, if we ignore the force of friction and the energy lost as thermal energy, we will find that the mechanical energy will be conserved. The mechanical energy will be the same in different cases. But what will differ? The potential energy or the kinetic energy? Sometimes the potential is 0, but the whole value for kinetic. Sometimes they will half and half. Sometimes more potential, less kinetic. Sometimes more kinetic, less potential. Sometimes 0 potential, but the whole value for the kinetic. But in general, the total mechanical energy is what is conserved. The total mechanical energy is conserved. It will remain the same. Okay? Is this point clear?
Yes.
Okay, you see here again, the potential energy 12 joules. Here he starts from a short height, so the potential was 12, but high speed, it's a high kinetic energy, 10 joules. So the mechanical energy will be 22. When it goes up, it has more potential energy. It has more potential energy because of increasing height. While the speed decreases, so it has the same mechanical energy but more potential and less kinetic. Okay, when it's falling down, it will again, if there is again number C, while it's falling down, the kinetic energy will increase more while the potential energy will decrease, but the mechanical energy will be still 22. Okay. Let's draw conclusions. Why does the ball's gravitational potential energy increase from point A to B? Who can tell me? The ball's gravitational potential energy increases. It was 12 joules, then it becomes 20 joules. Why? Because what increases? Haneen, can you try? Okay, Hazar raised her hand. Okay, Hazar, can you try, please?
Yes, because the distance increased.
The distance, which is the height. Excellent, Hazar. Excellent, because the height of the ball increases. So the gravitational potential energy increases. Hazar, how can we calculate the gravitational potential energy? Weight multiplied by height.
Weight multiplied by height.
Excellent. Weight multiplied by height. So if the height increases, the potential energy will increase. Excellent. Good girls. Then we will talk about that the mechanical energy or any kind of energy. We said before, what's the meaning of energy? Energy is the ability to do work. What's the meaning of energy? Energy is the ability to do work. So when I say mechanical, the object has a mechanical energy, so the object has the ability to do work due to its motion or due to its shape or due to its position. Yes, because the mechanical energy means the ability to do work due to this shape, due to this position, due to this motion. You remember when we said the definition of kinetic energy, we said the energy of motion or the ability to do work. The object has the ability to do work due to its motion. Okay, and so on. Let's here say what is the relation between mechanical energy and work. An object with mechanical energy can do work on another object, of course, because the object that has mechanical energy, maybe this energy due to its motion, due to its shape, due to its position, but it has the ability to do work on other objects. In fact, you can think of mechanical energy like all forms of energy, as we said, as the ability to do work. For example, a basketball does work on the net as it falls through the hoop. The net moves as a result. The more mechanical energy an object has, the more work it can do. Of course, the more energy an object has, the more its ability to do work, the more work it will do. The more mechanical energy the object has, the more the work it can do. For example, this bowling ball, if I will move it, it will have which kind of energy? Kinetic energy due to motion, and of course mechanical energy. Yes, if this ball I increase its speed, as I increase its speed more and more, it will cause more and more work. When I increase the speed, so I will increase the kinetic energy, so increase the mechanical energy, so it will increase the ability to do more work. The ability to do work will be increased, so this ball can drop more and more bowling bottles. It can drop more and more bowling bottles. So as increase the energy, this will increase the ability to do work. This will increase the ability to do work, so it will let more bowling bottles to fall down. Okay, let's apply it. The bowling ball does work on the pins when it hits them. Why is the bowling ball able to do work? Why? Why, girls? Who can tell me? Why this bowling ball has the ability to do work? Because it has which kind of energy? Girls, Nada, can you share? Can you participate with me, Nada? Nada is not here.
Yes.
Okay,
Yes, miss.
Okay. Why is the bowling ball able to do work? Why? What do you think? Why this bowling ball, when I throw it, it will let these bottles fall down? It will do work. Why? Because it has what?
It has mass and speed.
Excellent. It has mass and speed, which means it has kinetic energy. Yes? It has kinetic energy due to its motion. Due to its motion, it has a kinetic energy. It has the ability to do work due to its motion. Yes? It has the ability to do work due to its motion. And since we are talking here more specifically about mechanical energy, so we will say it has kinetic energy, so it has a mechanical energy. So it has a mechanical energy. Since it's moving, it has a speed, it's moving, it has the ability to do work due to its motion, so it has a mechanical energy. Thank you, Nada. Okay, number 2, how should you throw the ball to maximize the amount of work it does on the bins? Who can share with me? Who can participate here? Yara, can you? How should you throw the ball to maximize the amount of work it does on the bins? I want to increase the amount of work. So what I have to do? In brief, I have to increase what? To increase the ability to do work, to increase the amount of work. I have to increase what?
Let's increase the speed.
Excellent. To increase the speed. If I will increase my force, first the force that I will pull, I will push this ball by, so I will increase its speed, so it will have more kinetic energy, so it will have more ability to do work, or it will increase its ability to do work. Okay? Excellent. Thank you, Yara. Okay, this is a challenging question. In the type of bowling shown in the photo, the ball has a mass of 7 kg. In candle beam bowling, the ball has a mass of about 1 kg. Does the ball with the greater mass, take care of the question, does the ball with the greater mass always have greater mechanical energy? If the ball with the greater mass, does the ball with the greater mass will always have greater mechanical energy than the ball of the smaller mass? I want Supergirl to answer this question. Who is ready? Will the ball with the greater mass always have greater mechanical energy than the ball with the smaller mass? Questions like this we use to think about it. How we think about it? First, write the equation. Mechanical energy equal to potential energy plus kinetic energy. So potential energy, weight times height. Kinetic energy, mass time, half mass times speed to the power 2. So we have many factors affecting the mechanical energy. Here we are talking about bowling ball, so we are talking about kinetic energy, mainly about what? Kinetic energy. So we are talking about 2 factors. What are they? Kinetic energy depends on 2 factors. Just Nada said them. The mass and speed. Yes? The mass and the speed. So if one has more mass, it will have more kinetic energy. But in case that both of them have the same speed, what about if I have one with a large mass but very slow, very slow speed, and the other with the small mass has a very high speed? What about this? The kinetic energy may be equal, or maybe the kinetic energy of the smaller ball may be higher if its speed is very high. Yes? So it's a mass by its own. It cannot be, if the mass is always greater mass, this means that it means it not always give the greater mechanical energy, because we also depend on the speed. And also may this okay girls, maybe if the time finished, please rejoin again. Okay, also maybe this object that is great object has a very low speed, or maybe it's at rest. If it's at rest, it will have its kinetic energy 0. So we have 2 factors that detect or determine the kinetic energy, mass and speed. And here we are talking about mechanical energy. Also mechanical energy equal kinetic plus potential, but in this case there is no potential. The potential is 0, so we are talking about mainly kinetic. Maybe the kinetic energy is 0, okay, because the mechanical energy equals potential energy and kinetic energy. So we are not only talking about the kinetic energy. In case of mechanical energy is the sum of the potential energy and kinetic energy. So we are talking about both kinds, kinetic energy and potential energy. If I'm talking about just the mass, there is another factor in the kinetic energy, which is the speed. Also the potential energy, which is weight multiplied by height. Okay, girls? So having only the mass is not the only factor that I can determine which mechanical energy is greater. Is this clear? Girls, are you following?
Yes. Yeah.
Yes.
Okay. Let's answer this together. Yeah. Mechanical energy is the form of energy associated with what of an object. Who can answer? Yara? Associated with?
With motion,
Motion,
position, or shape.
position, or shape. Excellent, Yara. Thank you so much. Okay, number B. At a certain point, the kinetic energy of a falling apple is 5.2 joules, and its potential energy is 3.5 joules. What is its mechanical energy? Okay, Shams, can you participate with me? Shams? Shams?
Yes.
Yes, how are you? I have the
Fine.
kinetic energy of the apple is 5.2 joules and the potential energy is 3.5 joules. What is the mechanical energy? How can we calculate the mechanical energy? How can we calculate the mechanical energy? Please raise your voice, Shams. Okay. Who is?
Can I do?
Yes. Yes.
Miss, can I?
Yes, please.
Okay. First of all, mechanical energy is equal to
The sum of?
listen, يعني to the sum of potential energy and kinetic energy.
Excellent.
Plus kinetic energy.
Excellent.
So we will add 5.2 to the 3. We will add them.
Excellent. So it will give 8.7 joules. Thank you. Who are you, Aisha?
No, Miss Rimas.
Rimas. Thank you, Rimas. Okay. Okay, Aisha. By the way, let's start together. Okay. Let's answer this question. If an object's mechanical energy is equal to its potential energy, how much kinetic energy does the object have? Aisha. This is somewhat similar to this question. But in this question, we said that the bowling ball is moving, so it has mechanical energy equal the sum of potential energy and kinetic energy. Especially, we are talking here about kinetic energy, which is half mass times speed to the power 2. So if the mass is greater, this is not the only factor that, it's not my only parameter. I have another factor that we can say, which is the speed. If it has faster, the small ball has greater speed, so it will have more kinetic energy, so more mechanical energy. Okay, so what about this question? It's the same idea. If the mechanical energy is equal to its potential energy, how much kinetic energy does the object have? How can we calculate? Okay, girls, who can answer? One of the girls who raised their hands, please.
Miss?
Yes, okay. Who are you, Haneen?
No, Miss, I'm Aisha.
Aisha, okay, حبيبتي. Yeah. If an object's mechanical energy is equal to its potential energy, how much kinetic energy does the object have? First of all, you will tell me, how can we calculate the mechanical energy?
Mechanical energy equal potential energy plus kinetic energy.
Excellent. If the whole mechanical energy of the object is equal to its potential energy, what about the kinetic energy?
Miss, it doesn't have the kinetic energy. It doesn't have.
It has, which is equal to, I talked about it in the previous question. If in the previous, when I say if the object at rest will have a kinetic energy equal to
5.2 joule.
0. The kinetic energy will be here if the object, say the mechanical energy is 100 in this case. which is equal to the potential energy, which is only also 100 joules. How much kinetic energy does the object have? You said that the
Zero.
mechanical energy equals the sum of potential plus kinetic. If the potential is 100, what about the kinetic? Must be zero,
Zero.
yes? This means
Yes,
that the object is
rest.
at rest. Excellent. So we have to write that mechanical energy. Of course, you have to start with the equation, as I used to tell you. Any question that has an equation, you have to write the equation. Mechanical energy equal to sum of potential energy plus kinetic energy. In this case, the potential energy equal to the mechanical energy. What about the kinetic? Kinetic equals zero. So
Zero.
when the object has kinetic energy zero, when it's at rest, it's not moving. Okay?
Yes.
Okay, thank you, Aisha. Imara, can you answer with me? Now I know you can find an object's mechanical energy by what? By adding what and what? Imara.
Potential energy plus kinetic energy.
Excellent, excellent. By adding the object's kinetic energy and potential energy. Okay, girls, I will let you, inshallah, see a video about the mechanical energy. But before it, I will just list other forms of energy. We'll just list them today. And next time, inshallah, we'll learn more about them. We have other forms of energy. We said that two basic kinds of energy of an object are potential energy and kinetic energy. But there are other forms of energy associated with the particles of the objects that are nuclear energy, thermal energy, electrical energy, electromagnetic energy, and chemical energy. These are forms of energy that are associated with the particles of the object. Nuclear energy, thermal energy, electrical energy, electromagnetic energy, and chemical energy. Inshallah, we'll learn them in details later. Now I want you to watch this video about mechanical energy. Any question in my lesson? In our lesson?
No.
Is it clear? Mechanical energy is the energy of or associated with motion, position, or shape of an object. It's the sum of a kinetic energy and potential energy. That's it. Okay, let's watch this video. Okay. Is the screen clear for you?
Yes.
Okay, girls, start.